Tungsten and filler selection. Deck 4. Gas tungsten arc welding stainless.
So if we're going to talk about gas tungsten arc welding, we should probably talk a little bit about tungsten. I'm not going to do the full deep dive into tungsten, but we'll touch on it, give you a good idea of what the hell this stuff is. So tungsten's got a really high density, number one, and it's about the same as uranium and gold. That's why they use it in tank killer rounds, because it's really dense. It's about 1 times denser than lead. So, and it's pretty hard. They fired out of these tank rounds. It was designed to kill Russian tanks back in the day. It's really, really robust, and by that, we've got a really high melting point. It melts at 6,200 degrees Fahrenheit, 3,700 plus or minus Kelvin. And that means that we can run a lot of current through it and it doesn't melt. So that's one of the great things about tungsten and why we use it. So tungsten basics. Well, it's a non-consumable electrode. We use it to carry the arc. And it must stay clean. If we don't keep it clean and uncontaminated, we're going to have problems. When we use shielding gases with this stuff, what we use is argon and helium. We can't use something that's got carbon dioxide in it. That carbon dioxide will break down, give us carbon and oxygen, and all kinds of bad things will happen to our tungsten. And then that kind of stuff will end up in our weld puddle. So we've got some common types of tungsten. I'm not going to go through them all. We've got serrated or CP, which would be pure, I think. And then you've got thoriated tungsten. So thoriated is a pretty common one. So 2% thoriated. They put things into the tungsten. They alloy it with it to give it different electrical characteristics. So they put 2% thorium in with the tungsten. They get this alloy, and it gives us electrical characteristics. So with this stuff, we get good arc stability. And this is really reliable for DC welding, direct current welding. If you look on the ends when you buy these little packs, how do we tell the tungsten apart? Well, the electrodes are color-coded. Each type of electrode has a little dab of paint on that first inch or so of the tungsten electrode so that we can figure out or know what is what. So when we're prepping our tungsten for use, here's some ideas on what it should look like. So you can see that we want to have it ground lengthwise. We don't want to grind radially. The arc's going to wander if we grind the point, if we grind it radially. So we get a much more stable arc if we grind it straight, if we grind it longitudinally. So sharp point for control, and like I said, no radial grinding on this stuff.
So when we're talking about electrode tip preparation, the shape of this electrode tip, this is going to be a variable that we need to keep track of depending on what we're welding. Sometimes we're going to have a sharp tip, sometimes we're going to have a hemispherical tip, sometimes we're going to have it balled up. Generally with the pointed electrode tip, we're going to use this for restricted areas, narrow places, and it's going to give us a really good current density while we're welding. So we usually use the pointed tip on thoriated electrodes, and other types such as zirconium or pure tungsten are going to get the hemispherical or balled up type. It's going to have a little rounder end on it than the pointed tip that we see here. So the pure and the zirconium types of electrodes, these are going to form a hemispherical or a balled tip. And we usually use this when we're welding with our alternative current. And this would be welding with aluminum, on aluminum. So this, and most of this I cut out of a military manual, so it kind of guides us through it, but I didn't give us the full, down and dirty on this. I'm just giving you a skim cut of it. So you produce a hemispherical electrode tip, and you do this. You're going to strike an arc on a piece of copper or scrap metal, and you're going to wait until the tip heats up, and then it's going to ball up like that. It's going to form on the end of the electrode. What could go wrong? Well, tungsten contamination. If you dip the electrode into the puddle, you're going to get contamination. You're going to leave little molten globule balls of tungsten in the weld metal, and it's going to show up on an X-ray. So, and what else could go wrong? Well, if we've got dirty tungsten, we can end up with a bad weld. So we need to regrind when needed. Can't go limp this thing along with, dirty tungsten or contaminated tungsten. Got to be a grown-up. Cycle out the tungsten or clean it up. Filler metal basics. All right, we're going to match the base metal to the material. I'm not going into a deep dive on the metallurgy of that, but when we're welding this stuff, we want to have the base material and the filler material being somewhat close match in regards to the chemical composition. A couple that you'll see that are pretty common filler materials are 308, 316, and if we're doing dissimilar metal welds, we use the 309 electrodes. We want to keep our electrodes clean and dry. We don't need to keep this is just wire, so we don't need to keep it in a rod oven or anything, but we want to keep it out of the water and the dirt and the mud and any other kind of contamination source situation. When we handle the filler rod, when we're welding, keep it in the gas coverage. Don't take it out of the gas coverage and then bring it back in. You're asking for contamination. Don't drag it across the surface of the material. You're asking for contamination. And we need to store it properly. Previous slide, we saw some racks for storing the material. So you don't want to just throw it on the ground and have issues with water or something else contaminating or munging up your filler material. So the bottom line, we need clean tungsten, correct filler metal, and we don't need shortcuts. Not going to help us.